Hello and welcome back. We have another day and another opportunity to learn a little bit more about perimeters. Now today's lesson is Module 7:15, and our learning target is I can solve word problems involving perimeter. We're going to go ahead and look at this application problem today. And it says Clara and Pedro each use 4 3-inch by 5-inch cards to make the rectangles below, whose rectangle has a greater perimeter. Before you pause the video, I want to point something out. Some of these problems that we're going to be doing today, you have to really pay attention to the wording and what they're saying. We've got a lot of numbers right here, 4 3-inch by 5-inch, and we want to make sure we know what they're talking about. I'm going to use a highlighter to show different parts. This part right here, 3-inch by 5-inch, is talking about each individual note card. This 4 is talking about how many note cards were used. And they did provide a picture, but in some of the problems that we'll be doing today, they won't provide a picture. And so we want to really look closely at what they're saying and try to figure it out. Now, go ahead and pause the video and try this out for yourself. And I'm going to go ahead and jump into my explanation for this problem. I'm going to change my pen size so it's a little bit smaller. Let's start with Clara's rectangle. Now, I hope you didn't confuse area and perimeter. The area for these two rectangles is going to be exactly the same because they used 4 note cards for both of them, and the note cards were all the same size. The distance around, though, might be a little bit different. So let's go ahead and see if they are different. The long sides of these note cards are 5 inches. So I'm going to go ahead and fill in these unknown, because they didn't give me the full length here. They just gave me each note card's length. 5 inches, 5 inches, 5 inches. This one is a short side, so it's 3 inches. This is another 5 inches, 5 inches, 5 inches, and 5 inches. And this would be a lot to add. 3 plus 5 plus 5 plus 5 plus 5 plus 3 plus 5 plus 5 plus 5 plus 5. It's just a lot of numbers. So we want to try to simplify this a little bit. So let's look at the number of 3's that I have. Okay, it looks like there are 2 3's. This is just another way of writing it. I want to add that together to my 5's, and I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 5's. And that's going to equal the perimeter of Claire's shape. So let's go ahead and put a C for Claire. Now, another way that I could write this is I could put this in parentheses and say 2 times 3 inches plus 8 times 5 inches. And these all equal the perimeter of Claire's shape. These two statements are both the same thing. 8 5's, the way that we find that is doing 8 times 5. 2 3's is 2 times 3. So it's just another way of writing it. I wanted to write it out so that you can see it written, and this is the way that you'll see it more often later on. And so I just want you to be more familiar with it and to really get comfortable seeing those parentheses. 2 times 3, 3, 6. So this is going to be 6 inches. And then 8 times 5. I'm going to do by 8s. So 8, 16, 24, 32, 40. If I would have done it by 5s, I would have gotten the same thing. So 40 inches. These all still are equal to C. And this one's easy to add together because there's a 0 in the 1's place, a 6 in the 1's place, 4 in the 10's place, and nothing in the 10's place here. So we know that the perimeter of Claire's shape is equal to 46 inches. And we're just using these variables to help us with that. Okay, I'm going to switch colors. Got to readjust this line size. Now let's look at Pedro's rectangle and see what we get. So these shorter sides are 3 inches. That did not change colors. These shorter sides are 3 inches. So let's go ahead and add those unknown lengths in. Because the opposite sides are the same when we're looking at rectangles. And really what we're doing is we're saying the opposite side of this rectangle is 3 inches. This is the same size, and the opposite side of that one is the same, so that one's also 3. The long edge of these cards is 5 inches. We could also just say, well, we know that the note cards are 3 by 5, and so it's got to be 5 inches because it's the longer side. Let's do the same thing we did over here. How many 3s do we have? We got 1, 2, 3, 4. So there are 4 3s. And 1, 2, 3, 4. 4 5s. And this is going to equal the perimeter of Pedro's rectangle. We'll use the letter P to represent that. Now, 4 3s is the same thing as 4 times 3. And our unit's inches. Over here, 4 times 5 inches. This is all still going to be equal to P. Let's do 4 times 3. We have 4, 8, 12. So 12 inches plus, I'm going to count my 5s here. I like 5s. 5, 10, 15, 20. Plus 20 inches is equal to the perimeter of Pedro's. And this is going to be 32 inches. And that's equal to Pedro's rectangle. Now that we have our answers, we can answer for the perimeters, we can see whose rectangle has a greater perimeter. And that's easy, it's just whichever one's bigger. Clara's got 46, Pedro's got 32, so the answer is Clara. We'll change our color once again, and we are going to say Clara has the bigger rectangle. Are the greater perimeter. Make sure that we answer the question that they're asking, word it the way that they do. So there's my answer. Clara has the greater perimeter. And we even know what the perimeter is, but it didn't ask us what it was. It just asked whose was greater. Let's go ahead and look at a couple of different problems. Now, on a lot of these, you won't be given a picture, and so you'll have to make your own. So Miguel glues a ribbon border around the edge of a 5-inch by 8-inch picture to create a frame. What is the total length of ribbon Miguel uses? So in this case, we're trying to picture a picture, which they are usually rectangles. And in this case, it's 5 inches. Oh, that's the wrong side. It doesn't really matter for figuring out the math, but if we really want to visualize it, we want to label it correctly. So 8 inches, and the shorter size is 5 inches. And they want to know what the total length is. 8 inches, 5 inches. So we can do 5 plus 8 plus 5 plus 8. And that's going to equal, we'll use an M for Miguel. Well, 5 plus 8 is 13, plus another 5 gets us to 18, plus another 8 gets us to 26. And so how much ribbon does Miguel use? We're going to say Miguel uses 26, and it was inches of ribbon. Now, when you're doing your problem set, I'm going to show you a couple different ways that you can show your work. If you like doing it on paper, I recommend getting a piece of scratch paper and doing it just like I did, with writing it out, drawing the picture, showing your work, and writing your answer out. I'll also show you how to do it on the computer at the end of this video. A building at Elmira College has a room shaped like a regular octagon. That's going to be helpful. Regular means that all the sides are the same length. The length of each side of the room is 5 feet. What is the perimeter of the room? So an octagon has 8 sides. Let's make sure that we got this. 1, 2, 3, 4, 5, 6, 7, 8. And each one is 5 feet. And I can go and label all these side lengths. It takes a little bit of time. I'll try to do it fast. How fast can Mr. Sayre do it? And still be able to read it? That's a whole nother question. So how many sides are there? Well, octagon, oct means 8. So there's 8 sides, and each one is 5 feet. So 5 feet times 8 is going to equal the perimeter of this room. And so 5, 10, 15, 20, 25, 30, 35, 40. Or we can count by 8s. 8, 16, 24, 32, 40. The perimeter is 40 feet. Now that I have my answer, I need to put it into my answer form. I'm going to say the perimeter of the room is did not finish spelling perimeter, is 40 feet. And there's my full answer. And I always like to put them in a box. Makes it easy to find the answer. Okay, we're going to skip to one of these harder questions where we really have to pay attention to what it's asking and what that means. The gym teacher uses tape to mark a 4-square court on the gym floor as shown. The outer square has a side length of 16 feet. What is the total length of tape the teacher uses to mark square A? So we're not looking at the full square. We're not looking at how much tape they used to mark off the entire court. We're just looking at how much tape did they use for square A. And it didn't tell us what the side length is, but it gave us some information. This is a 4-square court. And so all of these squares have the same length. The length from here to here is 16 feet, and there are 2 squares within that length. So since they are the same size, we're going to split this 16 equally. And there's a couple ways that we can do it. We can just write 16 divided by 2. We can use related math facts, and we can use like a variable like n to help us know what that number is going to be. And we can rewrite our facts. N times 2 is equal to 16. We try to figure out what that number is going to be. We can also have 2 little boxes, and we can just count to 16 and divide them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, if you do this method for division, it does take a little bit longer, and you want to make sure that you can see all of your dots and take your time on it so that you know you got it right. So how much does each square have? 1, 2, 3, 4, 5, 6, 7, 8. In this case, n is equal to 8. So I'm going to take from this drawing, I'm going to pull out square A. And I know that the side length now is 8 feet. Since it's a square, this is 8 feet, this is 8 feet, this is 8 feet. Okay, and I can use multiplication to help me answer this. 8 feet, there are 4 of them, and that's going to equal the amount of tape that they used. So we'll use T. 8 times 4, 8, 16, 24, 32. So we have 32 feet is equal to T. And now we just have to answer our question here. We're going to say the teacher uses 32 feet of tape. Again, I always like to put my answers in boxes. Makes it nice and easy to find later. Until tomorrow, I hope you stay safe and, of course, have some fun. I miss you guys. I'll see you tomorrow. Bye.